So we are going to do 6-3 today. Now, don't get too scared of the title of it, Proofs of Parallelograms. We're not really going to do official proofs of this thing, but we are going to talk about parallelograms again, but in a different way. We did this, what did we do this with? With triangles. We did with this, I think, with triangles, I believe. Anyway, let's just take a look. I'm going to show you the difference. I'll tell you what. Do I have any? Nah, that was the other one. I thought I had some parallelograms. I got parallelograms over here. Oh, yeah, I do have a parallelogram. Look at that. That's good. Now I don't have to draw it. Just copy and paste it. Okay, so watch. This lesson is very, very similar to what we've done in the past, but with a slight little twist. Okay, the slight little twist was this. It said, let's listen. It said this. All the stuff that we talked about parallelograms before said, if this is a parallelogram, then all this stuff is true. Okay, we learned quite a few things already about a parallelogram. By definition, what did we learn about the parallelogram? We learned that what's true about the opposite sides. By definition, they're parallel to each other. So this side and this side are parallel. This side and this side. Monte, you watching? Okay. So these are parallel. But watch what we started with. We said if it's a what? Parallelogram, then all this stuff is true. I'll put ... Okay? You with me on that? The if part. It says if it's a parallelogram, then we know a bunch of stuff about it. We know that the opposite sides are parallel. What else do we know if it's a parallelogram? The opposite sides are equal to each other. Anybody remember this? Yeah, we've done this, okay? The opposite sides are equal to each other. We also learned something about the opposite angles. What's true about the opposite angles? Just say it. They're equal to each other as well. So these two are equal. Does that mean all four of them are equal, though? No, only if the parallelogram was a rectangle, correct? Would you agree? If all four angles were equal, then it would have to be a rectangle, right? But anyway, the opposite angles are equal. We also talked about the diagonals. Remember that? What's true about the diagonals of a parallelogram? What do? They're not equal to each other, but they do something else. So if that was 5, how much is this little bit right here? That's 5. We learned that, right? So if this was 7, then what's this? That's 7. So what do they do to each other? They split each other in half, but what's the good geometry word that we use for that? What is it? I heard it. Bisect. They bisect each other, okay? So we've learned a lot of stuff about parallelograms up to this point. But the thing is, again, I want to stress this. The thing that's different today compared to what we did before is that we knew that it was a parallelogram, okay? I knew it was a parallelogram. So if it's a parallelogram, then all this stuff that we just talked about has got to be true. You with me? Mm-hmm. Okay. Here's the difference. Let's get rid of all this and put this back here. Here's the difference. We don't know that it's a parallelogram just yet. All we know is it's a what? Looking at it. I didn't mark anything. So what's the only thing you can truthfully say about this? It's a what? It's a quadrilateral, okay? It's a 4-sided figure, okay? So we don't know anything else about it. All we know is that we have a quadrilateral. But they're going to tell you some things about this quadrilateral, and then what we're going to say is, if we know this about this quadrilateral, then you know it's a parallelogram, okay? So right now, just looking at it without anything marked, I didn't say it was a parallelogram. I didn't see any sides were equal, any sides are parallel, any angles were equal. You don't know anything about this thing except you got 4 sides, okay? But here's the first theorem. The first theorem, I'll just write the word out. There's no names for these theorems, okay? They number them, but we don't remember the number. That's ridiculous. Some teachers actually have you memorize the number of the theorem and then memorize the theorem itself. In fact, I don't know where I saw this. I don't know if I read it online or I saw it on a YouTube video comments or something like that, but somebody was talking about theorems, geometry teachers, making kids memorize theorems, okay? And a lot of teachers will do this. A lot of geometry teachers will make you memorize all the theorems. They'll say, okay, this is section 6.3, right? So that might be like 6.3 or 6.3.1 or something, okay? Because it's section 6.3 is the first theorem, so they call it that. And some teachers will make you memorize the number of the theorem, and they'll make you memorize the theorem itself, and you're going to have to write it out. I think that's ridiculous. And a lot of teachers actually agreed with me on that, on the whatever I was reading. I think it was a comment section to YouTube maybe. And they were agreeing that, you know, it's crazy to memorize the theorems, because if you don't know really what they mean, what's the use in memorizing, you know? So I'm trying to get you to understand what these theorems mean, and not necessarily to memorize word for word what the theorem says. And you should be very grateful for that, because I know that there's teachers out there that do it. All right, but here's what this theorem basically says. It says, if it's a quadrilateral, before we knew that this was a parallelogram, but right now, this is the difference. If it's a quadrilateral, I'll just shorten it, then, I'm sorry, we got to know some more stuff. And then we know some stuff about it. So we know it's a quadrilateral. Here's what the first theorem says. If this is a quadrilateral, and both opposite sides are congruent to each other. Now watch. If these two are equal to each other and these two are equal to each other, what do you think then we could call this thing? Well, it's a quadrilateral to begin with, without knowing anything. But knowing that the opposite sides are equal, what do you think we can say about this thing now? It's a parallelogram, okay? It's a parallelogram. So that means if it's a parallelogram now, then all the other stuff that we knew about parallelograms must be true about this. The opposite angles are equal, the opposite sides are parallel, the diagonals bisect each other, all that good stuff. Everybody see that? So the difference is, at the beginning, I didn't know it was a parallelogram. All I knew was a quadrilateral, but they told me a few things about it. They told me that the opposite sides were the opposite sides were equal to each other, okay? So if the opposite sides are equal to each other, then, right? So if it's a quadrilateral, and I'll just shorten all these things, the opposite sides are equal, comma, then what is this thing? It's a what? Come on, we just said it. If all this stuff is true about this quadrilateral, if these two sides are equal and these two sides are equal, what does it make this thing now? It's a parallelogram. So if you have a quadrilateral and the opposite sides are equal, then this figure right here, this polygon, is a what? Parallelogram. And we got a symbol for parallelogram. I'll just write that. That's basically what the theorem says. All right? Okay, so we have a four-sided figure, a quadrilateral. If I was able to tell you that these two sides were equal and those two sides right here were equal, then we know this is a what? A parallelogram. Now it's a parallelogram, okay? Before I told you that these two sides and these two sides were equal, I didn't know that it was a parallelogram. I mean, it kind of looked like it, didn't it? But I couldn't say for sure that it was a parallelogram. Now I can say for sure it's a parallelogram. So they're going to have questions on the homeworks and the quiz and the test and all that kind of stuff. And they're going to give you a quadrilateral. They're going to give you some information about it, and you have to tell me if it's a parallelogram or not, or why is it a parallelogram, or what must be true about the other stuff in order for it to be a parallelogram. For instance, what if, let's get rid of these little marks right here. Get rid of these tick marks. Okay, so right now, do I know that's a parallelogram right now? No, nothing's marked on it. I don't know anything about it, okay? But what if I told you that this was 5 and this was 3, okay? Everybody watching? What must X be equal to, and what must Y be equal to in order for this thing to be a parallelogram? Okay? Yeah. Exactly. So X must have to equal 3, and Y must be equal to what? 5, in order to make that into a parallelogram. Okay, do you see the difference? It's a slight difference. It's a subtle difference from what we've done before. It used to be that they would say, oh, this is a parallelogram. If this side was 5, what's this side? Well, it's 5. But they don't say that this time. They say, here's a quadrilateral. This side is 5, this side is 3. What must be true about these other two sides in order for it to be a parallelogram? Okay? Again, it's a subtle difference. Some people will look at this and say, why even bother? Because we already talked about the opposite sides are equal. Why even bother? But that's what these theorems say. Okay? Here's another one that we really haven't done before. Okay? Here's what they give you. Right now, do I know that thing's a quadrilateral or a parallelogram right now? No, I don't know it is. Sure looks like one, probably is, but I don't know. I can't say for sure that it is because I don't know anything about any of the sides, any of the angles, any of the diagonals. I don't know anything about it except it's got 4 sides, okay? But what if I told you that this and this were equal to each other? Is that enough to say that this is a parallelogram? Is that enough? No. It's not enough, okay? I would have to show that these two sides are equal as well, okay? If I showed you that this side and this side were equal as well, then it would be a parallelogram. But they give you one more thing. They say that the sides are also parallel to each other. Now, I'm not going to do the proof for this. I'm just going to tell you that this is enough information. I don't have to know anything about these two sides. If all I know is that these two are equal and parallel, that's enough to say that it's a parallelogram. Do you hear me? All right. So if I give one set of sides, if only one pair of opposite sides are both equal and parallel, then it's a parallelogram. So let's basically write this theorem out again. So here's what the theorem basically says. Okay. If you have a quadrilateral, okay, and the opposite sides and one pair, let's say that. Let's say one pair of opposite sides are both equal and parallel, then what could we call this figure then? If I know that one pair of opposite sides are both equal and parallel, what can I say about this whole thing now? Then it's a what? It's a parallelogram, right? It's going to be the same answer every time, okay? So you shouldn't even have to think about it. Parallelogram. I guess I could have just written a little picture for it, but there you go. All right? So if you have a 4-sided figure, and if one pair of opposite sides, if you know two things about it, if they're both equal to each other and they're both parallel to each other, that's enough to say that this is a parallelogram. So if it's a parallelogram, what could I say about this angle up at the top left and this angle down the bottom right? What could I say about those? I could say they're equal to each other, couldn't I? Because it's a parallelogram and opposite sides or opposite angles are equal to each other, okay? If I had diagonals in here, we'll put diagonals in another one pretty soon here. If I put diagonals, what could I say about the diagonals? They would bisect each other, okay? You with me on that? So now, just knowing that these two things are true, I can say that that's a parallelogram, all right? Let's keep going. We got a couple more of these to do. All right. So, again, do I know that this is a parallelogram right now the way it's written? Do I know it's a parallelogram? Come on, I've asked this question like twice already, 3 times maybe. I don't know it's a parallelogram just yet, do I? Okay, but here's what they're going to tell you. They're going to tell you, I'll tell you what, let's mark these. I didn't mark these on my notes, but let's just do it right now. What if I said that angle A was equal to angle C? Is that enough to say that this is a parallelogram? No. But what else would have to be true about the angles? Yeah, B and D would be equal, okay? What if angle B was equal to angle D? Now, what can I say about this quadrilateral, this 4-sided figure? What can I say about it? It's a parallelogram, exactly right, okay? So if you wanted to write the theorem out, you would say, if you have a quadrilateral, when both pairs of opposite angles are equal to each other, Okay? So if I have a parallelogram and these two angles are equal and these two angles are equal, the opposite angles, if I can show that, then what do I know about this whole entire thing? Then I know it's a what? Parallelogram. So now, if it's a parallelogram, what could I say about AB and DC? They're equal, okay, and they're opposite, but they're parallel to each other, right? What could I say about AD and BC? They're opposite, and they're also, or they're opposite, they're equal to each other, okay, and they're also parallel to each other. Agree? All right? So if you just know this stuff, then you could tell me stuff about the sides of them as well. Because why? Because we know that's a parallelogram now. All right? See what they're doing? All right. They don't tell you it's a parallelogram to begin with. They just give you some stuff in the parallelogram, some stuff that's equal, and now we can decide. We can say that now this is a parallelogram. All right? Let's do one more of these. All right. There we go. One more. So we said we were going to do diagonals. Let's do that now. So there's one diagonal. And here's another diagonal. Let's do some different color. Let's go blue. All right. So you got a quadrilateral. Again, I don't know that that's a parallelogram. Even putting those diagonals in there, does that tell me that it's a parallelogram? No. Okay, you can put diagonals in anything, all right? Pretty much anything. And it doesn't mean it's a parallelogram. But here's what I'm going to, I'll tell you what, let's do this. We'll go color coordinated here. If I can grab that thing. Where is it? Did I already grab it? Yeah, I did. What if you said, well, let's just do it like this. What if you said that those two are equal to each other, all right? And these two are equal to each other. Is that enough to say that this is a parallelogram? Absolutely, because what's true about the diagonals? What are they doing to each other? Give me a good word, good geometry word. We said it earlier today. They bisect each other, okay? They bisect each other, okay? So that means both of them are being bisected. So if I told you that the length of this was 5, what would the length of this be? This little bit right here. It'd be 5, okay? What about this one? What if this was, I don't know, 8? What would this one right here be? Or what if I said the whole thing was 12? The whole yellow one was 12. What would it be from here to the middle? It'd be 6. Everybody got that? Okay, because they bisect each other. They split each other in half. That's what bisect each other means. We good? All right. So that's what this theorem basically says. If you have a quadrilateral, again, we don't know it's a parallelogram yet. We know it's a quadrilateral, and the diagonals actually bisect each other. So we know this stuff, the stuff that I marked, those little tick marks, they tell us that that's true. Then what can I say about this whole entire quadrilateral? I can say now it's a what? It's a parallelogram, okay? And what must be true about a parallelogram then? All the opposite sides are equal, the opposite sides are parallel, the opposite angles are equal. So everything we know about a parallelogram, now we could say about this thing right here. Because I've shown, that's why they call it proofs of parallelograms, because we kind of proved that the four-sided figure, the quadrilateral, is now a parallelogram. Okay? All right. So how in the world are we going to do this on the problems? That's what you're more interested in anything, isn't it? How to do the problems on the quiz and the test? Sure. So here's an example. Yes. Pink and red. Well, the red doesn't show up very well. I'll use pink when after I draw these pictures. Okay. So here's what it says. Number 1, example 1. It says determine. Here's what's questioned. Here's the stuff that. Here's the question they're going to ask you on the homework and on the quiz and on the test. All right. I got 2 people with their heads down, making better progress than before. Only 2 now. All right. So let's take a look. It says determine whether each quadrilateral can be shown to be a parallelogram. So they're going to give you something. They're going to give you some information, and you have to decide, is this a parallelogram or not? Well, what if you just guessed? What kind of a chance would you get? 50-50, right. Because you just want to show, is it a parallelogram? Is it not a parallelogram? 50-50, it's a coin toss. Exactly right, okay? But listen, do you want your grade to be determined on a coin toss? Of course not. You want to know what percent would you like to know if you got the problem right or not? 100%, okay? So let's draw, I'll tell you what, I'll just use that same picture. Looks a little different in the book, but it's okay. Same idea. So what if they give you this? Let's do this. What if they, now right now, do I know it's a parallelogram right now? No. So I can't say it, okay, one way or the other. What if I just gave those two sides equal to each other? Could I say it's a parallelogram now? No, I got to know some other stuff. So they tell you other stuff, all right? And I'll tell you what, you want to use pink, we'll use pink. So let's say this is 108 degrees, and let's say this was 72 degrees. Now, you're going to have to think a little bit on this, okay? Because we never said it. None of our theorems had anything to do with consecutive angles, did they? All right, but we can figure something out. If you got, look at these two. They're not just random numbers. They're not just random numbers. What is true about 108 and 72? What do? They add up to 180, okay? So that must mean that they are, give me a good geometry word, supplementary, okay? But look at what you have. You got these two. What forms these two angles? Well, this line right here, let's label these, A, B, C, D, all right? So look, they use different letters in the book, sorry. I just picked A, B, C, D. So AB and BC, do you know that they're parallel to each other just yet? Not just yet. But you do know because these two lines are cut by a transversal. Does everybody see that? Look, I've got two lines cut by a transversal, right? They don't go through, they stop, but they could go through, right? All right, and this is what? 108, and this is 72. Do you remember this? Okay, if you have consecutive interior angles that are cut by a let's say that again. If you have two lines cut by a transversal, and if the consecutive interior angles are supplementary, what must be true about these two lines? They must be what? It hasn't been that long, come on. This angle right here and this angle right here are supplementary to each other, okay? They're consecutive interior angles. What must be true then about these lines if these two angles are supplementary? Take a wild guess. But you're going to answer a question. So disappointing.
Then I'm going to carry you the rest of the year.
Say it. They're not equal. They're parallel. Right. They're parallel to each other. So look at this. Look, this angle right here and this angle right here, they're not equal, but they are supplementary, aren't they? What must be true about the two lines that they both connect? Do you see it? This connects to here, this connects to here. What's true about these two lines if these are supplementary? Then AD must be what to BC? They must be, come on, follow along in my little story here. Okay, they're parallel to each other. So now check out what we have. We have a quadrilateral with one pair of opposite sides. They're both equal to each other and they're parallel to each other. So what must be true about this quadrilateral? Then
and one pair of opposite sides are equal.
And congruent, right? So it must be what? What must be true about this four-sided figure? It's a parallelogram. That's right. So yes, it's a parallelogram. That's our game. We're trying to see parallelogram or not parallelogram. What is it? Yes, it's a parallelogram. Okay? Everybody got it? You with me on this? All right. Let's do another one. Let's go. So let's do another one. She comes back. Here we go. Let's label it. Oops, what am I doing? There we go. I'll label it the way they do in the book. M, J. All right, everybody watch. Now, here's what they give you. What does it look like to your naked eye right there? Looks like a rectangle, okay? But it doesn't mean it is. It could be off just a little bit, okay? It may be like 90.001 degrees. Who knows, okay? We don't really know. But we can only go by the information they give us, all right? You can't just go by what it looks like. You have to go by the information that they give you. So they give you that these two angles are equal to each other, and they give you that these two angles right here are equal to each other. Okay? Is that the information that we need to know in order to say that that's a parallelogram? Why not?
Because
You got two pairs of equal angles. I thought we had a theorem that said if you
opposite
had
angles.
there you go. The theorem said that the opposite angles had to be equal to each other. Are the opposite angles here equal to each other? No, they're not. So can we say that this is a parallelogram? No, we cannot. No, it's not a what? Parallelogram. I'll just put a little symbol there instead of writing it all out. Okay? Everybody with me on that? Okay. Let's do another one.
Yes.
Same looking picture. All right. Kind of looks like a rectangle. Oh, oops. I don't want to do that. Do this. Kind of looks like a rectangle, doesn't it? But I can only go by the information that they give you. So we'll label this X, Y, Z, and a W, X, Y, Z right there. Okay? And here's what they tell you. They don't tell you anything just yet. All right? But if I put a, oops. I always think I'm going to go to the color. It doesn't change. There we go. Should work this time. So watch. This is a right angle right here. And watch this. This is a right angle right there. Is that enough information to say that this is a parallelogram?
Yes.
If these two are right angles, does that mean that these two are right angles? Nah, it doesn't really mean that, does it? Because I could do this. Well, not a triangle, because I need four sides. Okay, but watch this. What if I did this and I did this? Look at the whole thing. Forget this little bit right here, okay? Look at this whole entire thing. Is this a parallelogram? It's not a parallelogram. It's a what? It's a trapezoid, isn't it? Just because these two are equal, the only thing that this makes true about this thing is it turns this and this parallel to each other. Okay? Because here's two lines cut by transversal. The alternate or the consecutive interior angles are supplementary. Okay, that means that these two are parallel. Does that mean that these have to be parallel right here, though? X, we'll call this Q. All right. Does YQ and XW have to be parallel? No. Okay. Just because these two are equal does not make it. So what's our answer? Our answer is no. It's not a what? A parallelogram. Yes.
If XW and YZ were equal sides, would that make it a parallelogram?
No. Well, if they told you that X, Y, and WZ were equal to each other, that would make it a parallelogram. But knowing that this and this, I'm trying to figure out a situation where I'm trying to figure out a situation if this and this. I'd have to think about that. I can't think of it off the top of my head. But it doesn't fit any of our theorems, though. Okay, just because these two are parallel and these two are equal, that doesn't mean it's a parallelogram. But if this is the height from here to here. I don't know. I'd have to think about that. It's a good question, though. All right. Let's do one more example and we'll be finished, okay? Example 2. Everybody's writing all this down, right? Yeah, I keep saying it, but I still see a lot of people not writing and no paper. I know. I said, I didn't say everybody. I just said that there's a lot of people that aren't writing anything. All right? And that's probably not a good thing. But it's your grade. I guess you can do whatever you want.
When you guys take a test,
Let me. All right, here we go. Just had to flip that around a little bit, make it look a little bit like the book. There we go. And let's make it look about like that. Okay, that's kind of what the book looks like. Are you writing this down? You should be writing it down. All this talking and looking around, I'm seeing. which means you're not writing. All right, so they give you this. This is the kind of stuff that you're gonna see on the homework, on the quiz, on the test. All right, we'll do this in that pink again. This right here is 5A. Now, where is that? And there's a T in the middle. We'll put a T right there. Sorry, it should have been white, but that's okay. So 5A is from where? It's from Q to what? To T, right? And then they also make from T to S, they make that 20. Then from P to T, they make it 6B plus 2. And then they make the other one 7B minus 4. Okay? Now, here we go. This looks very similar. This looks very similar to what we've done before. We listening? Attention span of a gnat. Here we go. Right now, let's listen, because you're gonna have to do these problems, okay? And I'm showing you how to work them. Why are people out in the hallway?
The Eagles landing this year. Stop now.
You don't even know what that means.
You're about to find
Do you
out.
know what the eagle? You know what that means? The eagle is landing. Do you know you know where that comes from?
We have a singing grand for Bryce.
Oh, what?
From Anonymous.
What?
Oh wow.
It's from me, Bryce. So.
Jeff is singing Bryce.
We made certain, not just you.
Come on, you're wasting my time. Come on. Singing telegram. All right, come on.
Baby, you light up my world like nobody else. The way that you flip your hair gets me overwhelmed. But when you smile, I put down really hard to touch. You know you're beautiful. Oh, that's what makes you beautiful.
Another one for Mr.
Who's it from?
Anonymous.
What? No, it's not.
It's from Nico, John, and
That's right.
Jake.
Oh, it's in my pocket.
Oh, yeah.
yeah. It's from Nico, John, Jake, and Bryce.
Yeah!
This was
My
5
best
bucks,
student.
Mr. Hammer. I deserve an egg.
When I see your face,
What is this?
there's not a thing that I would change. 'Cause you're amazing,
You got that
just the way you are. And when you smile, the whole world stops and stares for a while. 'Cause you're amazing,
Amen.
just the way you are.
Yo, you want to
Yeah, we did.
That was the perfect song.
Yeah, that was the perfect song.
You need a leaf.
All right, thanks, guys.
Was it really? Alright, Bryce, you can sing it. Bryce, sing it. You guys are the best. Thank you.
You guys suck.
That's like best.
What is happening? I'm never going to pay that. That price.
All right,
That's the best laugh I've ever said.
thank you.
Mr. Hammer,
right. What was the song supposed to be?
Anonymous, and they picked the wrong song.
What was the?
Never gonna give you up.
You got Rickroll.
No, it was a good song. All right, here we go. We got to do this. We got 3 minutes. Okay, we got 2 minutes now. Here we go. Where are you going? Sit up. Okay, sit up. Seriously? All right, here we go. What are we going to do? Now watch. What do I need to do, or what is A and B going to equal if this was a parallelogram? So watch. No, let's wait till class is over. I got to finish this problem. I got to finish this problem. So look. So watch. How do I find A? We're not leaving until we finish this problem. So, you know. So let's take a look. What do I do? What do I do here in order to show that this is a parallelogram? You got diagonals, so the diagonals must do what to each other? Okay, if the diagonals bisect each other, then that makes this thing a parallelogram. So let's find what A is supposed to be in order for it to bisect. So let's do this. So what must be true? 5A is what? Equal to 20. What's A equal then? A must be what? 5? Come on. You guys are scaring me. All right? Yes. It does. It fills me with... We're not leaving. Hold up. I said we're not leaving. We're not leaving. So watch. Let's get B by itself. So subtract a 6B from both sides. You get B. Everybody see that? Then what do? Add a 4 to both sides. You get 6. And there you go. Now listen. Listen to me now. The assignment that I have on your lesson plans for Tuesday, it says we're going to go over them in class or something like that. That's going to be due tomorrow, okay? And then tomorrow, I'll assign this stuff right here, all right? So tomorrow, you're going to turn in whatever it is, 6-2. So you're going to turn in 6-2 tomorrow.